Okay, so today too, I want us to solve questions and see how we can relate the formulas I taught already. Okay, so if you've not watched the video, please kindly go and watch it. I'm talking about these ones. We have proved all the formulas and how we can use them in solving questions. So if you've not watched it, please kindly go and watch it. So let's solve today's question. So this is the question on board. The question says we should convert minus 1 minus root 2 to rho theta phi. So what this one is telling us is that we should convert. You see, looking at this represents x, y, z. So it means we are converting from coordinate to, and this one rho theta phi represents sphere. So that's the coordinate for sphere. So it means we are converting from coordinate to sphere. So we know the relationship between rho and the coordinate x, y, z. We know that rho is equal to square root of x squared plus y squared plus z squared. So just make your substitution, then you are good to go. You are going to get rho to be 2. Then we've learned that the relationship between rho, phi, and z is that z is equal to rho cos phi. So we can use this relationship to also find the value of the phi. Okay, so because we've already known the value of rho to be 2, so you can put 2 here, and you know the z from our question to be negative root 2, so negative root 2. So you just make phi the subject, so you are going to get phi should be equal to 135 degrees. But remember, we can also convert from degrees to radians. So just divide by 180 and you are going to get 3 over 4 pi. Okay, so after we are done, now we are done with the value for phi. We have also find the value for rho. It's left with the theta. That's why I said that in terms, or when we are given the coordinate system and we have been asked to convert to a spherical coordinate system, theta is not the same. Okay, theta is not the same. Unlike from cylindrical coordinate to spherical coordinate. For cylindrical coordinate to spherical coordinate, theta is the same. But from coordinate systems to spherical coordinate, theta is not the same. So it means that we have to link the x and y to theta. And how can I link it? So we are going to get, we proved from our previous videos, we did that. We saw this formula and we've explained it. So we saw that y is equal to rho sine theta sine phi. So you are going to get the y here from the question. Y is 1. So just put 1 there. Rho 2, you find the rho to be 2. Okay, then you know your phi to be 135. This is the phi, 135. So you just make a substitution, then you make theta the subject. So you are going to get theta to be sine inverse of root 2 on 2, which is 45. Okay, so you are going to get, we are done because we've known the value of theta. We have also find the value of phi, and we have also find the value of rho. So what we are left is that you just write them in terms of the coordinates. You are going to get 2, which is the rho, comma theta, 3 pi on 4, comma, okay, there's supposed to be comma here, comma 3 pi on 4. Okay, so that's it. So the reason why I didn't write theta to be pi over 4 is that we found out that the theta was 45 degrees, and 45 degrees will be somewhere here on the first quadrant. Okay, and we are also measuring the angle. Remember, when we were proving the equations, we were taking the angle from the y-axis here. Okay, so it means that because we are getting 45 here, we can subtract it from 180 for us to get the angle here, okay, on the second quadrant. And when we do that, we are going to get 180 minus 45, which is 135. And you convert 135 to the radians, then you are going to get 3 pi on 4. Then the phi is also 3 pi on 4. Then 3 pi on 4. So that's it. So please, if you've not watched the videos on how to prove them and how to use them, kindly go and watch it. Thank you very much.